Um, so good morning, everyone. So I'm Miriam. I am representing TPG as part of Geneva Living Lab, and I will walk you through the current state of our project, Collaborative Mobility Digital Platform. We call it CMDP. And I highlight with you the key components that structure the project. Here's an overview. CMDP stands for Collaborative Mobility Digital Platform. It's a 2-year project that we conduct in partnership with ETH Zurich and other partners that are more operational, such as PT operator in Lausanne and also the city of Lausanne. And our ambition with CMDP is to establish a collaborative open source digital ecosystem enabling the development of advanced agent-based transport models. So, CMDP aims to make the development and use of agent-based models seamless, automated, reproducible, and also scalable across regions. And by integrating various data sources such as the traffic counts, passenger counts that we have at TPG, GPS traces, the tool will allow us not only to represent the current state of mobility behaviors, but as well to test future scenarios in a consistent and evidence-based manner based on predictive algorithm. So this is an approach applied in Geneva and also in Lausanne. So if I go back to the timeline, the project started in April this year. It will last 2 years. And first, ETH develops the tool at the national level. And in February, two submodels will be extracted from this national model for Lausanne on one side and for Geneva on the other side. And these two models will be refined based on local data during 5 months, and then will be operational, we hope, in September 2026 to be tested with future scenarios, and so we can see how robust the model is actually. And the project itself will end by April 2027. I'll go through the main tools behind CMDP. So CMDP relies on 3 major open sources frameworks. Maxim, which is widely adopted. It's a widely adopted multi-agent transport simulation platform. We have Equasim framework, which is a Python-based pipeline for creating agent-based scenarios based on open source data. And then the final tool is ODTP, which is called Open Digital Twin Platform, and it actually makes it possible to store and execute the tools and also store the results. So together, all these 3 tools work together and build the CMDP itself. Maybe I'll walk you through what is agent-based modeling to start. So Maxim is one of a agent-based model that exists today, and it makes it possible to simulate mobility by representing each component as agent, such as people, vehicles, operators. So this is allowing us to analyze dynamic interactions. Most of traditional models are more static and provide average mean values. It also makes it possible to analyze behavioral choices, global impact, but also very fine disaggregate impacts, such as mobility hubs level or station levels. And it also makes it possible for us to analyze the impact of various policy and strategies the authorities would like to implement. So this is a very granular, fine microscopic tool, and the scope could be as regional but also system-wide. And it will help us in the future to help the authority in defining policies for transportation. Has any one of you heard of Matsim? Just maybe a thumbs up if you do, so I know that I don't need to go through. Okay, I see one thumbs up. Maybe I'll go through anyway. So Matsim is an open source tool. It has been developed for 20 years now by TU Berlin and also Zurich. The repository is available on GitHub. There's a dedicated website as well that you can access to through the presentation later on. There's also a book, a manual, a guide that exists but is not really up to date. I think the easier way to go through Matsim is probably through the website for you to discover. And it's actually a tool that is used for quite a long time now all over the world by various companies and also authorities. Here in Switzerland, it's used by our national train company, SBB, and then various German companies as well. But not only in Europe, also in Australia and so on. And there's also every year 1 to 2 member user meeting that happen and bring together 50 to 100 people. I think last year it happened, or maybe this year it happened in Berlin. I think no, not 2 weeks ago. That's old. It was in Munich in June. So sorry, it's not up to date. I'll change that. So how does it work? Matsim simulates mobility as the result of millions of individual decisions. So each simulated traveler, which is called agent, has a detailed activity plan describing when and where the travel happens and how they do it, for which purpose, with the which mode, and so on. And this tool runs the simulation interactively, meaning agents perform their fully daily schedule, and the system measures their performance over the day for each agent: travel time, waiting time, congestion, penalties for delays, and so on. And after each iteration, a small proportion of these people, these agents, usually between 5 to 10%, are allowed to innovate. They can choose a different route, they can change mode, they can change the departure time, adjust their activity timing, and so on. And each iteration is scored again, and then only the best plans are kept in memory. And through these repeated simulation and learn cycles, Matsim converges to a stochastic user equilibrium, a stable state where no agent significantly improved their travel experience. So this is how it works. And because every agent and vehicle are simulated at a microscopic level and recalculated at every iteration, Matsim provides a highly detailed result overview of network dynamics, congestions, and behavioral responses. Again, if you have any questions, please interrupt me, so it's more interactive. If not, I'll go through the second tool, which is Equasim. It's more like a pipeline. Everything is written in Python. Matsim is in Java, and this pipeline helps us to create scenarios to put as input to Matsim. It's used also in Switzerland, Germany, Europe, also in the US. It's also open source, so you can find everything here. How it works. So it's a pipeline that helps to process data and build scenarios really as a backbone for our tool in the end, which is called CMDP. And it transforms raw statistical and transport data into a fully detailed synthetic population, ready to be simulated in Matsim. So Equasim starts from reliable sources such as census data, national travel surveys, commuting matrices, and so on, transport networks, of course. And from these inputs, it constructs a population where each individual has realistic socio-demographic attributes such as age, gender, income, employment status, car access, and so on, and has also a complete daily activity schedule. So the tool uses behavioral models derived from a travel survey to assign modes, destination choices, and timing decisions. And once the population is generated, Equasim converts everything into MathSim format as input data, producing a scenario that can be simulated repeatedly, calibrated, and explored. So one of its great strengths is to make analysis reproducible and consistent across regions and datasets. Maybe just an overview of what we use in Switzerland for CMDP at least. So we have statistic from the population. This is quite must be a bit obscure for you, but this is related to the population, related to the business activities. We also have commuting matrices in Switzerland, and then that we kind of cross all these data sources to end up with a synthetic population with very fine attributes and also an activity daily plan. And of course, data from for road network and also transport network that are available publicly. I'll go through maybe just how the synthetic population is created very quickly. So using these statistical modeling and iterative, I mean, it's IPF, iterative proportional fitting, sorry. Equasim creates a synthetic population where each individual is representative of real demographics. So for each person, we have assigned an age class, gender, households, employment status, as I mentioned before, access to car, and location, where you work, where you live, where you study. And this ensures spatial accuracy and demographic realism. And then Equasim builds a detailed daily plan for each agent, a sequence of activities such as home, work, leisure, and home again over the day. When it starts, when it ends, what are the travel purposes, how long last the activities, and so on. So here you have an overview of how Equasim works. Then we'll go through the last tool, which is which make it possible to actually run the other tools and to store results. So EDTP itself, it's a open digital twin platform. This is its full name. And it has been developed by ETH Zurich. It's quite new. So as I said, it helps to store our tools and models, combine them into into CMDP, and it helps also executing the simulations, to track them, to reproduce them, and it provides access also to the model configuration itself. So this is a kind of the envelope. So this is how CMDP works, and it's also open source. And how now that you have an overview of how this CMDP is structured and what are its components, I wanted just to go through with you on how CMDP makes it possible to go beyond the state of the art. I think what is the most interesting for us as PT operator is that it makes calibration automatic, as it is a very time-consuming job to calibrate models to make sure that they are accurate in reproducing an observed situation, so that we can use them to predict the future. By making calibration automatic based on observed data, this will reduce significantly the time that we need and resources for this job. Also, what is known with MathSim, it's that it takes a lot of time to compute. So ETH is actually working on improving the speed of the algorithm, and also how to use various data sets to enrich the model. Yeah, that's basically it, but it's a lot actually. And now, what can we expect from CMDP? What are the results? So eventually in April 2027, when it's fully operational, both in Lausanne and in Geneva, CMDP should be able to deliver detailed representation of the population and its characteristics, precise activity schedules, individual trip trajectories at link level or bus line level or stop level. For instance, it will also make it possible to provide vehicle movements, which is it interests you as it interests us, sorry, as a PT operator. And eventually it will also go with a dashboard, a web map that will make it possible for us and also for public authorities who are not manipulating the model to understand what are the results and the effects of various of the tested strategies or policies that we want to analyze. So if we go maybe a bit more into details with the use cases, also regarding intermodality and new shared modes, is that CMDP is very well suited to analyze intermodal mobility and the integration of NSM, which is increasingly central here in Geneva. So CMDP models not just individual trips, but complete door-to-door mobility chains, as explained before. So we will see a combination of walking, PT, shared bikes, e-scooters, car sharing, and so on. Also on-demand services. So this will allow us to simulate first and last mile strategies and evaluate the role of mobility hubs that we are implementing today. So this will help us understand how users shift between modes when new mobility options become available. And CMDP can also simulate how shared mobility interacts with public transportation, whether it replaces it, whether it complements it, or helps increase accessibility to high capacity lines. So with the integration of new datasets and behavioral models, CMDP will help us to evaluate, to assess the deployment of NSM, of mobility hubs, and it will provide us and also the public authorities with a robust tool to support decisions on investments, service configurations, line extensions, pricing strategies, and multimodal integrations. So that's it. Today, I just wanted to tell you where we stand, as we are still in development, and it's mainly HH working right now, as we will have the Geneva model to play with only in February, starting February next year. So HH is still focusing on how the whole thing can be automatically calibrated. We also have a researcher working on refining public transport validation, public transport assignment, sorry, which is done on Swiss Raptor, which is also available. Everything is available on GitHub. And especially we want to make it possible to see how we can assign routes combining not only walking and PT, but also shared bikes, private bikes, e-scooters, and so on. And also refining the pricing model, which is quite complex, especially at the national level, as we have various zoning systems and so on. And I just also wanted to go with you through the web map that is already available, just for you to see how it looks like. So if we have a few minutes left, I don't know, Sayali, let me know, interrupt me if I'm too long.
I think we have a couple of more minutes and then questions.
Great. I'll just share the other screen with the web map. There. So you should see the map of Switzerland. If not, just say so.
We do see it.
Perfect. Thank you. So this is what has been done today at national level, and then it will be refined at Geneva level and also Lausanne level. Well, the canton of Vaud. And we have various possibilities to display results, to display both observed data today. I don't know if I select Geneva, for instance, and if we want to see, we can see what, for instance, the model renders in terms of traffic. If we want to see the traffic for buses in terms of vehicle this time, we can see how it is displayed by the model. We can see the volumes on links as well and change the time of the day. We can compare the results of, for instance, mode choice by distances. And I wanted to show you the comparison between what has been modeled by CMDP and what is observed. And this is available not everywhere. This is available, for instance, activity distribution. Yeah. So this is what the model produces for the synthetic population in terms of number activities per day, for instance. And here it is compared with a reference database, which is our microcensus. Unfortunately, the last one happened in 2020, so we don't use it because of COVID, obviously. So we use 2015, which is quite old, but then the new one will be delivered beginning of 2026, we hope. So this will help us to provide a more accurate and fresh model based on this new reference data that we'll be using for calibration as well. Here you have also different features for the frequent activity sequences. Here you have a home, work, home, 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 leisure, home, and so on. If I go back to modes, what we like to check as PT operators are, I think this is interesting. Let's see. See here you have all the stops for bus network. I can change for tram network. We have a few lines here, and also see you can see the volumes that are over the day, over the full reference day, both boarding and alighting at every stop for trams. We don't have any ferry, but if I go back to buses, it's a more panoramic overview. So as you can see, we have various features that are already available today. Some part of course, of the web map are missing because what we want to see is actually the comparison between traffic counts that are observed and traffic counts that are modeled to validate the model first, and then once it's validated, once we consider that this is accurate enough, then do projections, not only on the assignment part, but also on the demand part for mode choice and so on, to make sure that the model is robust enough. And that's it for me. If you have any questions, first, thank you for your attention, and I hope it was interesting for you. And please feel free to ask questions if you have any.
Thank you, Miriam. I see two questions here. I'm not sure who was the first one, so I go with Panos and then Safira.
Hi, hello. Thank you, Miriam, for the presentation. Very
Safira start.
interesting. Did you say Safira?
No, you say start. Okay, no problem.
Okay, sorry, I don't see the queue
It's
order.
okay. You can start, Safira.
I did already,
You go
so
next.
thank you, Miriam, for the presentation. One question, if you could, let's stay in the screen where you were. Is it possible to see also the results on link or at least corridor level when it comes to flows per mode? For example, corridors where you have both the bus and car, for example, or is it only for the public transport data that you will be focused?
You're right. Thank you for mentioning that. It's actually a multimodal tool, so we will be able to see not only traffic for PT through corridors or specific lanes, but also for cars and obviously on-demand services that will be running through now more all through Geneva. We hope in the future. So no, we can see every mode from walking, biking, private or shared, private cars, and so on.
And do you have already some validation result? I understood correctly that so far you've done the validation with the data from 2020, but you're waiting for the new data set of 2026, or
It actually depends. For instance, for road traffic, we are using traffic counts from Google from 2018. For the demand, we are using a census survey from 2015 because the one that has been done in 2020 is a bit biased by the COVID crisis. And we wait for the new release in 2026 that should be delivered at the beginning of the year to recalibrate the model based on this new data. We are forced to work with quite old data because of COVID.
Yeah.
Waiting for the new ones to come.
Yeah, that's typical, I think, for many PTOs. But back to the validation question, do you have already some results, even with the previous data sets, on how the model performed in a more low-level resolution, like corridor or
Still in process. Algorithm are calibrated currently, so we are not at this step where we consider, okay, let's see if the results are good enough. We are meeting with our authorities both in Vaud and in Geneva next week to establish the kind of the standards for validations. For instance, what are the reference values for us to use to define, okay, beyond this threshold we're good and above we're not, for instance. So first we will have to define these validation standards for calibration, both demand and both assignment, with them to make sure that they are on board and actually, okay, say, we agree these models are robust enough, we will be using them, because this is what we hope eventually is that this model will not stay in a box, in an academic box, but will be actually used by people, by PT operators, and by public authorities. So unfortunately, we're not that far yet.
Okay, I understand. Good. And one last question, if I have some more time. Could you show the slide with the digital twin framework?
Yes. Let me go back through it. Okay, I have it. I'll share it. Do you see my screen? Oops. Yes. Is it the right one?
No, there was one with the definition of this ODTP, I think.
Mm-hmm. Oh, ODTP, sorry, not CMDP.
ODTP, I think.
Yes, sorry. Yes, here we
Okay.
are.
Right. So because I wasn't really sure I understand what this does.
It's a container. It's like a Docker container. If it helps, it really is just a kind of a shell that will make it possible to execute, to run the other tools, Equasim and Matsim,
Okay.
and to
So
also store.
okay, because so it's not about the representation of the transport network per se. It's more of
No, you're right. Yeah.
okay,
It's
more
just the tool
technical.
used to contain everything else. Yep.
Okay, I see. Okay, thank you.
Panos, maybe you can ask the question.
Yes. Okay. Hello, Miriam. Thank you. Actually, I am also a user of Matsim, and I was in the meeting in Munich. But okay, ATH has much more expertise than me on developing matching models. One thing that I thought during your presentation is if we can use the outputs or some of the things from I know Matsim has a very detailed simulation output. If we can use them some way in order to feed also the open data platform presented before. That there is no clear evaluation framework, or I know very agent-based models have not been connected with evaluation frameworks. So this one recommendation I thought during the meeting, but as far as I understood, you are in the process of validating that model.
Yes.
Okay. So yes, it's not the best idea to add an evaluation framework, very simulation data. But I would be open to discuss how we can use this simulation outputs, what metrics, what indicators we can calculate from a base simulation that you have now. For example, we have some indicators which are very generic, CO2 emissions, which still rely on a calculation with some assumptions. So basically now, all approaches have assumptions. When you want to calculate CO2 emissions, all the approaches have assumptions, except if you have one count in each car, and then you. So I'm very interested in the research part, how an open digital twin platform be connected with evaluation framework like the one we have now in SAM. Like a general thought.
Oh, that's great. Maybe we could have a discussion, the two of us, or any of your colleagues, if you think it's interesting for them also to be involved.
Yes, I will.
To see how we could create that bond. Yeah.
Yeah. Because sometimes, yes, I understand the simulation that sometimes for policy making, maybe they will not be useful. But if we can use some outputs and some indices for our planning process, then we may have this connection between academia and very high quality simulations and what is decided at the end. Okay.
It's a bit a pity that some ends so soon, because we won't be ready, at least at national level, before February, and at Geneva level even September. So after the end of the project, but still it is interesting to think what comes after SAM, because there is something after SAM, maybe another project. So we can definitely start the discussion now and see how we can find combine this evaluation
I think
framework.
we should start the discussion. We should start the
Okay.
discussion because there is no other way to estimate impacts in air pollution, environmental impacts, without some assumptions or some simulations. There is no other way. Okay. We cannot have hard data from reality about all this stuff. So why not we do not use simulations after one point and do some small calculations with many assumptions. This is my why not replacing the seats we have about CO2 emissions with simulation model, like a future direction.
Thank you.
Thank you for your feedback and the suggestion. I think maybe you could also discuss this further bilaterally and involve all other interested parties here for the first discussion round. We would end this session if there are no more questions, and then I will give it over to Daniel. Are there any more questions? I see no. So